Okay, hello. I think I think I just show my face. Okay. Sounds more respectful. Okay. Hello. Okay, and including those of you who watch the recording. Okay. So, okay, even though we have not much people joining, but it's okay. Yeah, I think let us share about some general info about this competition. Okay. Um. Yeah. Let me share my screen. Okay, you can see, right? Okay. So, so let's talk about some general info. Okay. So, so this competition will be held on 12th of October. I think it's a Saturday or Sunday. I think most probably a Saturday because last year also Saturday. And then, okay, this exam got East and West lah. So we are in the East Division. Okay, and then it consists of two paper. So one paper is like 3 hour. Okay, looks like much, but if you all finish earlier or you all don't want to continue, you all can leave early also. And the registration fee is completely free lah. And then all of us can join. All of us in UPM can join. And just if you are interested later, so you just can just ask me or maybe you can PM Dr. Chen. Okay, if you I'm sure you all know who is Dr. Chen. If you all don't know, just also let me know also. Okay, and then one more thing very important is this competition can be in either individual or in pair. So means that if you all like don't want to like seorang je, like you all want to have some friends and you can like want to discuss, so you all can like find your friends and join as a pair. Yeah. The paper will be totally the same, just that you all can be in a pair lah. Yeah, just like that only lah. You all want to ask anything, you just ask me lah. Then I just reply you. Okay. And yeah, so okay, let's go to. I think background I just skip lah. Rule also skip lah. So right, so as you can see here lah, participating university. So we are one of it. Actually, not much of a university joiner, but luckily we have that. Yeah, after some effort that we are able to register it. So yeah, and then okay. So from this website, you all can look at the problems if you want to look at the problems like from 2017 and then up to last year. Okay, and then more sample problem. But if you are a beginner, actually I suggest that maybe you don't want to start from this one as like most of you are saying that if you all like look at the past year, it is like too crazy. I'm not sure if yes, then actually we have like some because this is like a actually quite high quality competition. So I think that of course the problem will be like uh maybe even you say me when I go to say it like out of the 8 question, maybe I only like do maybe 2 or 3 only. Yeah, that much only. So the rest of it I actually I I don't I have no idea also. Yeah. So yeah. And then okay, the topic cover is like actually university mathematics lah. So like from what if you are maths and statistics students, so I'm sure that you all have covered calculus, statistics, and linear algebra, and what else? I think basic algebra. Yeah. So yeah, I think that's such topic lah. Okay. Actually, the question will not be like too difficult to understand, but maybe the techniques involved. Actually, from what I observe lah, most of the question are actually we can understand what the question want, but just that to figure out the solution, or like maybe it will be a little bit abstract, but it's okay lah. So I think later we can try to look at some of the problem, and yeah, let's just have some let's just have a look on what type of the question like we can do. Okay, so I will stop share here, and then I think let me share. Let me share like yeah. I think before we start, oh yeah, oh yeah, sorry. Okay, actually, I want to like let you all have a look on what are the material that you all can use. So here I will share a link. Yeah. Okay. I'm keep uh I'm keep updating this drive lah. So actually I have put some resources in this drive. Um yeah. Eh, wait. Uh yeah. I think yeah. Let me try to. Okay. Like if you look at this one, so here are some of the like the books that I recommend. So like for university maths, so these are the few topics that that we all do lah. Okay, so I'm sure that if you are a math student, then you all know most of the topic like linear algebra and calculus and statistic. Okay, and then number theory also quite a lot, and also complex analysis. And okay, so these are the topics like that like but don't think like you will like ask everything about this subject. No, but just maybe some of the useful thing. Okay, I think later I will share one more things that you all can try to go to, which is uh actually I have a friend in UM. So he like every Saturday he will do the training session for the SMMC. So like cover some basic topics like for all those students, even if you are not math student. So from the beginning one. So if you are interested, then later I will let you all or you all just contact me, or okay, maybe you can do like WhatsApp group or like that, right? Okay, so here are some of it. I think I think maybe that's it. Yeah, I mean for those of you who just joined, okay, I think let me just have a quick review on what I've just said. So for this competition, okay, we can join as an individual or as a pair. So if you are a first time jump, you are scared about the question, or you all can like join as a pair. Okay, so means like you all can sembang with your friend, like during the competition, like you all can work together. If you scare to being alone in the competition or whatnot. Yeah. So that's my suggestion. Okay. Yeah, because like or you all like don't feel like, oh, this one the question is too difficult or what, because as what I know from our friend UM, last year they have like 10 participants. So but then if I'm not mistaken, actually this one to to say like win something actually is very difficult for us as Malaysian, because because the highest because the highest marks in Malaysia actually just consider like maybe 1/3 of the overall score. So like compared to Singapore, compared to like Australian, yeah, actually our score is just like maybe not even half of them. But what I'm trying to say is that maybe we can give some chance lah, like just like maybe if you like spending 1 hour to like maybe can understand one question, I think that is already a very good trial. Yeah. Okay. So I think maybe we can just like start. So here is a file that I prepared. I think you will have it already. So after I looking at the past few question, so this is some of the question that I think that is suitable for a beginner to start with. Yeah. So but of course lah, out of except for this one from the Google Drive link, yeah, from the Google Drive link, I think I send one more time for those who just joined. Okay. Yeah, for those who just joined, you can look at this one. So inside that actually I could put some university textbook, and then oh yeah, by the way, here's one more which is called this one. This book is for competition maths using. So it will like cover most of the topic, like most of the important topic lah. Okay. Especially when you want to start with the maths, maybe like mathematical induction. I'm sure that some of you know already. And Pigeonhole principle, one of the quite important technique. Yeah, and then so on. Yeah. So it's like this one is like a general one, like the general one. But if you straight away start to reading this one, maybe it'll be like too heavy. So maybe you can just like a better one is you can try some other competition books, including IMO. IMO, but not the really the IMO one, but it's the basic one. In our Malaysia team, there's a competition called IMO and ST, IMONS. So that one is like for beginner to start with, and if you are past the test, then you all can go further. Yeah. So I just type in the chat box. This one, you all can go search for more information about it. I think during in the drive letter I will upload also. I think got already. I'm not sure. I'm not sure. I think I will upload the some file from iMons because that one is suitable for beginner to start. So if you are first time to like first time to like this one. Okay. So I think can we like try some? Maybe you can like try some. So just like I try to choose the question that actually use most of the basic concept that we can know lah. Okay. Yeah. So I'm sure that everyone of you know like polynomial integration and some geometry. Quite easy one. Quite easy. Okay. So I think let's just start. Okay. So like during the technique to solve, like maybe maybe you can like see what are the technique require. This one just a special one. So like the general one, what's the pattern? Okay. Yeah. We'll just start. Okay. So let's look at this one. Okay. So let ABCD be a unit square. Let P be a point inside the triangle ABC. So I think it's something about geometry. So it's very suitable that we start from drawing lah. So if you have a paper or you have a tablet, so let's just draw something. Okay, so then you label as ABCD. And unit square means there's a length one. Okay, unit. And then let P to be a point inside the triangle ABC. So I think you can draw a triangle ABC here. Okay, so maybe P is a point inside it. This is a point P. Okay. I mean, when you read the question, like maybe you feel like, oh, too much of a story, like is it very difficult? But when you see actually, I try to use not more than what you have learned. Okay, let E and F the point on AB and AD respectively. So E is AD, so AB is this line. AB is this line, so maybe just draw a point. Agak on here. E. Okay. Another one. Sorry, AD. AD, which is here. Okay. F. Okay. Respectively such that AEPF is a rectangle. So you search for AEPF lah. Okay, you search for AEPF. It's a rectangle. Okay. Now, if you just simply join these 4 points, of course it is not a rectangle lah, right? Of course it's not a rectangle. So maybe like drawing something, of course, is yes possible. Like one of the most easier way to see what happened. But when you draw something which is not a condition, so you may erase something and then draw back one more time. See how to fulfill the condition. Like this one is a rectangle, so we can move the point A cannot move lah. E, F, and P. We move these 3 points so that it looks like a rectangle. Yeah, we can try that. I think let's have a guess lah. Okay, if it is a rectangle, means that this one is 1. Okay, no problem. I think I just erase that. If it is a rectangle, means that these 2 points must be the same height, right? Because like if you want to draw a rectangle, it almost be like that. So if this one P is here, the E must be the same height as this one. So we can also move this point F, go here. So this one now, it looks like a rectangle already, right? So this is a rectangle. Just for us to imagine what happened later. Okay. And then, yeah, done. Then we continue to read. Let X and Y denote the lengths of AE and AF. Okay, so let's draw out the length. X is AE, so this one, X. Okay, AF is Y. All right. Okay. Okay. Now, see, determine the 2 variable polynomial. Okay. Now, when you look at it, like, wait, what is polynomial? What is 2 variable polynomial? Like, when you think too much. Okay, but you all know what is polynomial, right? Like 1 variable. Like 1 variable polynomial is just like, for example, quadratic lah, okay, or maybe power 4 plus 3 power x power 3, like, and then maybe minus x squared, and so on, right? Maybe plus a constant. This one is a 1 variable polynomial lah. So if like 2 variable, actually just add something. If this one variable polynomial, the general term looks like this. An x power n. So means that your power can be x power something lah, some integer power, positive integer power. Okay, but if x, y 2 variable polynomial, it means that maybe you can have some term x and y combination, and maybe you can have some x higher power, y lower power, or maybe some just y alone maybe, and maybe like so something like that, which means a combination of linear combination, if you know this one, like linear combination of the term with x power something, y power something. So maybe a general term is like this. Yeah, something like that. But that's fine. At least you know what is something like just like a function between that only. But without looking at that, even though you don't know about this, okay, that's okay lah. I just erase this. Okay, like determine something. Just think of a function only. Okay, find a function with the property that the area of AEPF, which is this rectangle, Okay, what is the area of AEPF? Right, this one is very easy, right? You already have X, you already have Y. Of course, the rectangle area is X multiply Y lah. Okay, so we can write the area AEPF is equal to XY. Okay, okay, is greater than the area of each of the quadrilateral, this one and this one. Okay, and if and only if, okay, this one letter, okay, okay, this one greater than this, greater than something, right? Okay, greater than something. Okay, each of the, so this one might be scary. Area of each of the quadrilateral EBCP. Okay, let's write out what is EBCP and also what is the area of FPCD. Yeah, we write out them respectively lah. Okay, EBCP. Okay, let's draw lah. So EBCP is this one, right? This one. Oh, so sorry. This one, and then joining here, joining here. Hello. Okay, one more time. Like this. Okay. Now this one is AECP. Okay, AECP. Okay, AECP, the area. Okay, I think this one not really bad. Like if you figure out this one, we already given this one is a unit square. So this is 1. So this is also 1. Like find out this area, I think it's not very difficult because you already know also this one is X. So this one is total is 1. So of course this one must be 1 minus X. Okay. And then this is Y also. So this one is 1, the length. Okay. Yeah. I think if you want to find area of this one, you can just separate to 2 parts, and one is rectangle, one is a triangle. Yeah, I think that's quite easy. Okay, let's just figure out what is the area. So the rectangle is 1 minus X multiplied by Y. Okay. Separate. Okay, don't confuse. Okay, and then plus the triangle. Okay, this one rectangle plus the triangle. So the triangle is, of course, you must have the height and the base. So this one, without this part, should be 1 minus Y, right? 1 minus Y. Yeah, minus 1. Okay. So 1/2 multiply 1 minus X and then 1 minus Y, right? If you all want to like say something, you can just type in chat box or what you want to say also, it's okay. But just that I'm actually recording lah. But you all can type. Type 1C. You just type lah. Like you have anything not understand or just like concern about something. I think this is just geometry only lah. So I think still okay, maybe. Okay, so this is the area of EBCP. Okay. Okay, you want to simplify lah, okay? Or I just leave like that only. Okay, let's try to find the other one. FPCD. Try FPCD. Let's join them. Let's join them using this one. Okay. Okay, this area is, okay, we're using the same argument. Using same argument. Okay, so this is 1 minus Y. This is also 1. And then this one is X. Okay, so to calculate this area also we separate to 2 parts. One rectangle and one triangle. So for the rectangle part is X times 1 minus Y. And for the triangle part is, so I think we need this area also, which is 1 minus X, right? So 1 minus X and 1 minus Y and 1/2. Yeah, I think it's exactly the same as, yeah. You just separate 2 parts. plus 1 over 2, 1 minus x, and then 1 minus y. Like that. Okay. Okay. Right. Okay. Okay, now you see, I think you can simplify maybe. Okay, now, but let's again read about the question now. Like, okay. Now, the area of this one is greater than area of each. Mesti dua, right? So this one must bigger than this. At the same time, it must also bigger than this. So it's like two things must hold together. Two conditions must hold together. So this one greater than this. At the same time, also it is greater than the other one. Let's make two equation. Okay, so let's make two equation. So this one xy greater than this, and at the same time xy also greater than that. Okay. Okay. Oh, never mind lah. Just separate. Okay. So xy greater than this one. So at the same time also, so when I say at the same time, like if you have some you don't know what is n and all, right? N and all. So when I say at the same time, it means n. Okay. Both conditions must satisfy together. So it's something like, yeah, basic logic. So xy also greater than this one. Okay. Now, yeah, I think, yeah. Okay. Okay. Now, I think we can ask one question. Like, okay. So now we already say this one, right? Okay, but let's look at the last part. Say if and only if, okay, this one f xy, the function greater than 0. So from what we have now, can we like construct some function greater than 0? Actually, we already have the inequality here, greater something. This one is also greater something. So our final job is just to do some algebra. And then finally, I want to find fxy greater than 0. So what is the fxy? So this is our job. So this is our job. Okay. Now you have two inequality. Now you think like, which one have to use, right? Okay. Now we actually need to eliminate something. Okay. Okay. Let's look about this. Let's look about these two area, the green color one and the purple color one, right? Purple color is this one. Now, which one do you think is bigger, green or purple? Which one do you think is a greater one? I think quite obvious from here, but you say like why it is necessary true, right? Okay, so you can look at one more time the condition back lah. Like you see, you say okay, P is a point inside the triangle ABC. Okay, using this fact, this is triangle ABC. Okay, and if point P is inside the lower triangle, okay, this one let's say there's an upper triangle, this is a lower triangle. Okay, so let's say P is here. So if you use P to construct this one and compare to this one, so of course, which one is bigger, right? Because P is in a lower triangle, it's in a lower triangle side, and use P to construct this pattern, this shape, and then use the upper one to construct this shape. Okay, from the diagonal, you can now like just compare. The green color one looks like smaller compared to the purple color one, correct? Right? Right. Okay. Okay. So now we can think about something. Okay. Now, if this area xy must greater than this one and this one at the same time. One is green, one is purple. Let me highlight lah. Let me highlight for you. I'll go somewhere. Yeah. Okay. Okay. One more purple color one. Okay. Okay, now like, okay, if the green color one is smaller and this one is bigger, okay, let me highlight in green. Let me highlight in purple. Okay, the relationship between the purple color one and the green color one. Okay, wait, I think this one too long, right? Or you guys just prefer like, let me just write out as A, E, P, C, P. And then this one as the area of FPCD. Okay, and then use this figure. The purple color one is greater than the green color one. So area of FPCD is greater than the area of EDCP. Like this. And the down one here is an AND statement. Okay, it's an AND statement. Okay, now, okay, I think somebody just joined only, but it's okay. So can I just continue? If you all need the recording, you all just let me know lah. I have the recording. Okay. Now, and statement, we have this one, right? Okay, XY greater than this. This one also greater than this. Okay. One thing in like in algebra called transitivity. Okay, like if X greater than Y and Y greater than Z, so we can just conclude X greater than Z. This is the like continue lah. Like 7 is bigger than 6, 6 is bigger than 5. Of course, we can tell 7 is greater than 5. Like that. Okay. Okay, but without doing this, okay. So this one is already greater than this. Okay. So now you see, this one is smaller, and then this one is bigger, but the bigger one is greater than the smaller one. So actually, these two information can be just can just be because we are saying the both condition must satisfy. Okay, both condition must satisfy. So this one must greater than the green color and must greater than the purple color one. Okay, now you think if it is already greater than the green color one, but not necessarily it is greater than the purple color one. Can be lie, the area can lie in the middle, right? Because now green color is smaller. So if this one is true, okay, this area greater than the green color one, it can lie somewhere between here. Not necessarily it must greater than the purple color one also. Okay, but if this one is true, if it is already greater than the purple color one, then from the purple color one greater than the green color one, we can tell also from if this one is true, we can imply this one. Okay, if XY greater than the purple color one and purple color greater than the green color one is already a fact that we know, then we can tell XY greater than the green color one. So now all the needed information is just the purple color one only. So it must greater than the purple color one. Okay. So this is what all we need. FP CD. Okay. Okay. Because this is like intersection, okay? N is about intersection, right? Okay, I give you a similar thing. Okay, I give you a similar thing. Okay, for example, X greater than 5 and X greater than 6. Okay, look at this one. Okay, now you draw a number line, X greater than 5, right? And you draw a number line, X greater than 6. This is 5, this is 6. Okay, now, one very useful thing is that N is always about intersection. And when we say OR, it's about union. So this one, I'm finding the intersection of both. Sorry, intersection. So intersection means that which both number line has the part, only this part, right? So we must choose this one. So the result will be X greater than 6 only. So this one can be eliminated. Right? So the result is the intersection is just x greater than 6. This part only. So it's a similar argument here. This one is like the 5, this one is like the 6. Okay, because 6 greater than 5, so all we need is just this one. So this is a similar case. Okay, a simple case. Just for you to see. Okay, picking n is an intersection. Okay, now with this one, okay, let's just substitute the purple color one with this. Okay, and then greater x, y, greater. And then let's do some algebra. So this is x minus xy plus 1/2 minus, okay, let's expand these two brackets. 1 minus x, 1 minus y, and if you expand the bracket, 1 minus x minus y plus xy, right? Okay, expand the bracket. Okay, now from here, maybe you want to do some simplification. This one is not necessary if you don't like. Okay, xy, x. Okay, this one can go here lah. So 2xy lah. And then 1/2 minus 1/2x minus 1/2y plus 1/2xy. Okay, let's group all the same term. Okay, now what is our final goal? If you look at here, the final goal say fxy greater than 0. Okay, so this is what you want to construct, right? fxy equal to 0. So if you just want to do like your final goal, remember, is put some function greater than 0. You want to determine what is the function fxy. Okay, so now let's move everything to the left-hand side. So this term is 2, this term is 1/2. So if you 2 minus 1/2 is 3/2 lah, 3/2 xy. And then 1 minus 1/2 is 1/2. Bring here is 1/2 x. And then y plus. And then minus 1/2. Okay, so your final result is like this one greater than 0. Okay, now actually you have done the job because your goal is to find a function, a polynomial, looks like polynomial but xy. Okay, and then this one greater than 0. So your conclusion is fxy equal to this. This is what you want to find, right? This. Or if you have some if you like, you'll see everything there's a common denominator 2. You can multiply both sides by 2, which is also give you the same thing because this one is still 0. So this one is 3xy minus x plus y minus 1. Oh. Or your answer can be this one. So both are correct. And finish. Yeah. So yeah, so that's it. Okay. What's your feeling about like this question? Too heavy, too difficult, too hard, or very easy? Like when you first look at the question, you might think like, oh, like cannot understand what the question want. I think this is most of the feeling that maybe you have. But when you like do one by one, step by step, and then you see actually it is not a very difficult question, not a very bad question, right? Just some combination of this one and that one. Then you put everything together. Yeah. Okay, so I think let's so this is the one of the geometry problem that I think is very suitable for you all to start with lah. Okay. Of course, here you can have more questions like this. So here are some of it lah. Okay, here are some of it lah. And yeah, and later I will attach my solution of this all question. of course, today we are not gonna to do everything, like that's impossible. So I think just some of it only. I think just the first picture maybe. Okay. Okay. Still okay? Mm, well, it's interesting to do the question already. Yeah. Well, I'm happy to see that, right? So like, yeah, right. Thank you for appreciation of this, even though this is not my question. Okay, anyway. All right. Let's look at next one. I'm picking which one to like use. Can I have a bias to look at this one 2003? Yeah, I think this is also a very nice problem. Okay, and let me tell you the thing that you need to know for this question. It's just uh it's just APGP, if you know APGP, right, in MX. And one more thing is you know about circle. I know about circle. The circle as a, yeah, you know about circle, and that's it. Okay, let's try to do this one. So this is 2003, which is last year question. And yeah, well, last year I was doing this. Okay, yeah, give me 10 seconds. Okay, so if you're okay, just let's follow up, because I feel like I see some of you has run away already. So I don't think like you think, oh, this one let's play. Okay, never mind lah. I think like actually most welcome lah. But maybe you will think like, oh, this one too difficult. But you actually haven't looked at it, right? So if you stay until one question end, I think like it's still okay, right? Still okay. Okay, let's try this one. Okay, but when you see Fibonacci, okay, never mind. This one just the name only, right? Okay, yeah, let's see. Okay, now, okay, for Q is between 0 and 1, so means that Q is a number. It's between that 0 and 1. Okay. Okay, so he calls some shape called Q Fibonacci spiral. Okay, we don't care about it. Okay, it's constructed as described below. Okay. Okay. Okay, constructed below. An arc of radius 1 is first drawn inside a 1 by 1 square. Okay, I think when you look at this, okay, or let us just draw it, right? Okay, this one is also the same thing, like 1 by 1 square is another 1 by 1 square. Okay, so this is a square. Okay, now arc of a radius 1 means it's a circle, right? So circle, we know there's a center and there's a radius, right? So okay, we try to draw something like this. Okay, almost follow the pattern. Okay, now if it is a 1 by 1 and we use a radius as 1, which means that we will use fully this one as our radius. So try to have an imagination about that. Okay, enough. Wait. Okay, I try to do this. Okay, so it means that it will step over this area. So this one is a radius 1. Okay, to construct the circle. Okay, it's a construct the circle. Actually, you see here, lah, right? See here. So this one is what we call the arc, lah. Okay, the arc. Or just do a circle using radius 1, but for just a quarter only, for 90 degree only. Okay, so this is what they want. Use this one and do this. Okay. Okay, now the second arc is then drawn in a Q by Q square. Then the third arc is drawn by Q square times Q square square. Okay, and so on. Okay. Okay. Now he gives some example like when Q is 1/2. Okay, now let's think about what is the next step. So you see, Q is some number between 0 and 1. Okay. Okay. Your first R is 1 by 1. Okay, it's 1 by 1. You use a 1 by 1 square. Now, your second square is q by q. So see this. Q by q square, and q is some number less than 1, which means it is a smaller square, right? It is a smaller square. So let's draw it over here. This is a q by q, q by q. So q, and this is q. Okay. And then if you continue to see, we want to continue the line here to here, which is another 90 degree, another 90 degree. Okay. Another 90 degree, and then this one is a circle, right? So circle. Just now was like this. And then the radius is 1. Now we have q by q. So let's just join this one and then draw this. Not very good. Right. This right? Okay. So 1 and 2. Okay. Still boleh ya? Okay. And then next, the third one is continue to have a q square. So which means your side length, when you go to the next square, your side length become multiply one more q. Okay, from 1 to q square to q cube, and so on. Okay, and so on. Okay, so the next one is over here. So this one is even smaller because q square, of course, q multiplied by another q, which is another number smaller by 1. Of course, it's smaller than the second one. So this is the third one. And if you draw this one from here, and this is the pattern looks like. Okay. And then you do the same step for infinitely many. Okay, infinitely many square. Okay, let's just draw the first three lah. Okay, first four, sorry. Okay, so this one is q cube. Okay, and then continue. And if you see, they have actually draws a picture. So this is how we construct them. Okay, this is how we construct them. So this one is when q equal to 1 over 2 lah. So when q equal to 1 over 2, you can check that like this one is half of the length. If this one is 1, so means this one is 1 over 2, 0.5 lah. And the third one is 1 over 2, 1 over 2, 1 over 4, or 0.2, 0.25. Right? This is 1, this is 0.5, this is 0.25. And so on. You keep dividing by 2, dividing by 2. So the square is like that. And you keep doing and then this one you eventually be a really small square, and the trace and this one the pattern of this one, you finally approach a point. Okay. So to create a continuous curve, right? Okay. So the example are given as follow. Wait, what they want? Wait, this one just like that only. Yeah, I think this question is incomplete. Let me search for the real question. I think I didn't copy completely. I think this one is 2003, right? Okay, let me have that. Yeah, it's incomplete. There's one more instruction. Okay. This one just tell the situation only. We haven't have this. So this is the okay. So this is the instruction. So the example of q equal to 1 over 2 and some number, that one, okay, is shown. Oh, well, before I want to tell something. In this competition, we can use calculator. Okay, calculator is allowed. So you can use calculator to check anything. Okay. Okay, and maybe you can try the number like square root 5 minus 1 over 2 is still a positive number less than 1. The pattern is like that. Okay. Anyway. Okay, let's try. Yeah. Prove that there exists a circle center at the initial of 1, 1 square such that center at the initial 1 by 1 square, for which it's a circle, such that for each 0 to 1, okay, the limiting endpoint is lies in the circle. Okay, so now we want to find the limit point. Okay, the limiting point, which means this one, right? Okay, and go through, right? So eventually it will go to a point. So like your goal is to find out what is this point. This point can, let it be some coordinate, right? Okay, try to find out this point. Like the distance is where is how much from the beginning. Okay, so for to do this, I think it's better to introduce this plane, right? To introduce this plane. Yeah, introduce a Cartesian plane, okay? X and Y coordinate, you all know about that, right? Okay. So, okay. And then this one is origin 0, 0. So from here, if you start to draw this one, I want to know what is the final point. Okay, this one continues, right? Continue. So I want to know what is this point, X, Y. What is the X, Y? Yeah, X, Y. That's the final point. The final point, let's just call the limiting endpoint. Okay, limiting endpoint. Okay, now you'll be like asking, hey, this one is very difficult to find. Like, how do you know, right? Okay, but let's observe some pattern. Okay, and we see how to find. Okay. Okay, now we will separate to two different jobs. Okay, two different jobs. Okay, one job is, let's find out the x coordinate first. Okay, the x coordinate of, okay, so let's say I don't care about the y coordinate. I just want to like know this one, and then later like this, and then later go here, go here. I want to know the pattern. Okay. Okay. So the first circle tell me I will go here by 1, right? So this is 1. Okay. The x, okay. X, y. Can I just have some notation? X prime, y prime, because x, y is this one, the plane. Okay, so let's say I want to find what is the x prime, x prime. Okay, right. So now you see the first square 1 by 1. I go from here to here, right? From left to right. So which means the coordinate of the x plus 1. So let me just write out 1. Okay. And then the next, in the second circle, and sorry, in the second square, also go from left to right. So okay, so I just care about this one only. Okay, I don't care about this one length how much. Okay, I don't care about that. I just care about the x coordinate change from here to here. So this length is how much? Is q. Okay, is q. So now the x coordinate plus a q. X coordinate plus a q. Right. Okay, and then the third one, in the third square, from here goes here. We just care about the left right direction only. I'm not care about the up down letter, the second task. Okay, the first task is left or right. So this one go from here to here, which is from left to right. Okay, so left to right means my x coordinate, this one I plus, this one I plus, so this one I minus. I minus with q square. This length is q square length, so minus q square. Okay, and the fourth one. Okay, the fourth one also minus, right? Go from right to left. So minus q. Okay. Okay. Now there's actually a pattern, right? Okay. If you cannot see, okay, never mind. But let's see. If you do one more, you plus or minus. The first two is plus. The second two, okay, the first two is plus, and then I minus and minus. What about the fifth one, and the sixth one, and 7, 8? I'll continue. Okay, let's say I do one more. So this one is q power 4, q power 4. Okay, I don't write out the signs, but this is a square. Macam-macam ini lah. So from here to here, the direction is going from, again, left to right, right? Right? From here to here. Left, right. Okay, from left to right. And then you will see this one go like this, go down. So this one is also left to right. So this one plus, this one also plus. For the x coordinate with plus and plus. Actually, it actually is similar in this situation. Okay, just like it will go a 90 degree, 90 degree, 90 degree, 90 degree, and then if you repeat the pattern from here, make one circle, okay, and then make another more circle. So you keep turning like that. So meaning that you will first plus 2 and then minus 2, and then plus one more, and then minus one more, minus one more. But the size is keep become smaller and smaller. Okay. So let's try to figure out. So just now I say plus 2 times, right? And you remember to add the power of q, and then minus 2 times. And then you continue this pattern, right? Plus q8, plus q9, and so on, and then minus, right? And then minus. Okay, so on. Okay, now you try to find out this value. Let's say, can we find out this value? Okay, it's my idea. Okay, why just now I say this one has something to do with, what do you think this one has some related topic with? Like when you see the first term is 1 and then q square, q power 3, q power 4, power 5, 6. Each term we adding another power, not adding, multiplying another term. So it's something to do with geometric progression, right? GP, okay, GP, right? And so on. But let's say you say q is the common ratio is, let's say you say, okay, this one common ratio is q, is it correct? But you check, okay, the first term is 1, yes, the second term is q, but the third term, if you follow this one must be q power 2, but it's a plus, but this one is a minus, so here is a problem. So I cannot set my r equal to q, so I cannot do it in this way. Okay, but you say, hey, this one got 2 positive, 2 negative, 2 positive, negative, but how? Okay, you have if let's say you have 1 positive term, 1 negative term, 1 positive, 1 negative, okay, that is doable, because let's say I give you an example, like 1/2 plus, 1/2 minus 1/4 plus 1/8 minus 1/16. Okay, this one is doable, because this one you can set your a, which is your first term. So this is some revision. Okay, so this is your first term, your a, and your common ratio, which your next term multiply by what? So to be your next term. But this one is positive, this one negative. So your r common ratio is negative 1/2. Okay, which for you to go from here to here, okay, and then this is negative, and multiply by negative 1/2, you get back positive, and 1/8. And then continue to do the same thing, negative 1/2, so you get a minus term. Okay, so a equal to 1/2, r equal to negative 1/2, and if you follow the formula for the GP for the infinity one, right, is a over 1 minus r, right? SPMMC. Okay. So let's say I follow this one. Okay, this one you all know, right? I mean 1/2 and then 1 minus negative 1/2. Then yeah, I think the answer is 1/3. Something like that. Okay, but this one just a revision. Okay, so now I want to see whether I can make 1 positive term, 1 negative term, 1 positive term. Okay, of course this one is not, but can I separate to two different sequence? so that I have positive, negative, and each term is multiplying by a same ratio or that, right? Okay, now this is how we do. Okay, let's see. Let's say I only consider this one, this one, this one, this one, this one. Okay, and I write them out. 1 minus q squared plus q power 4 minus q power 6 plus q power, and so on. Okay, so on. Okay, this one is the first one, and then I separate with the other one, which is this one. Okay, this one, this one, this one, this one. Okay, so this is starting from q, and then become minus, become plus, become minus, become plus. Now I think it's more like that case already, because let's say we just look at this one. Okay, the power is keep adding 2, which means we multiply by the same thing, which is q squared, but one is positive, one is negative. So this one tells us that the common ratio is a negative number, right? Okay, so let's identify the A and the R, and then we can do the sum, okay, using that formula. So this one, so this is the first series. This is the first series, and then this is the second one. All right. Okay, so this is the A for the first series. Okay, the first GP. A of the first GP, the first term of the first GP, and the common ratio for this one is negative q squared, right? R is negative q squared, the common ratio, right? So from 1 multiplied by negative q squared, it become negative q squared, and then multiply by negative, become positive, and then q squared, q power 4. And then do the same thing on this one, this one. Okay. Okay, then the second series also happen in a similar way. So now this one is the first term, A, and also the same thing happen. Your common ratio is also negative q squared. Okay. Okay, so from here we can tell. Okay, from here we can tell this one equal to what, right? Okay, so the pink color one, pink color series, we use that formula A over 1 minus R, which is negative q squared, right? Plus another series. So this one, the first term is q, A is q, and 1 minus R. R is also negative q squared. So something like that. Okay, and if we rearrange, so simplify 1 over 1 minus q squared, q over 1 plus q squared. Because the denominator is the same, so we can combine it as 1 over q over 1 plus q squared. Yeah. So this is the x coordinate. So the x prime, yeah, x prime. The x prime of this one. So this one, okay. I give you an example. Let's say q equal to 1 over 2. So you try to find out what is your x prime. And maybe 1 plus 1 over 2, and then 1 plus 1 over 2 square. You try to see this number. Okay. Over 1 plus 1 over 4. Okay, this is equal to 2. Okay. Which means that if you start from, if your q is 1 over 2, looks not really the same. Okay, never mind. Wait. Am I doing the right thing, right? Wait, 3 over 2 over 1 plus 1 over 4. Oh, sorry. I'm so sorry. This is not 2. This is 6 over 5. Right? 6 over 5. No. Yeah, 6 over 5, right? Okay. So which means that if my q is 1 over 2, so you go like that. So your final value from your origin, go to your this part is 6/5, which is 1.2. Your x value here is somewhere 1.2 from your origin. Here. Okay. Okay, now let's do the same thing for the y value also, right? Let's do something for y value also. Okay, this one will be a little bit long lah, but of course in a 3 hour time, like maybe you can figure out something that would be like even though you can't get a full mark also, but if you have some started drawing something, jotting something, yeah, I think you will also get some sufficiently enough mark. Okay, let's look at the y coordinate also. But we have an idea already, so the y coordinate will not be a problem for us now, right? I think can you all try figure out what's the y prime? Okay, let's try lah. Okay, y prime equal to, so what's your first first value? You need to plus or minus if you look at your first square. Now your job is to look at this first square. The trace is going up or going down. Don't look at left right already, because we have done the job for left right x. So now it's about the y value. So in the first square, our y value going up or going down. So that's it. And then you need to plus or minus, and what is the length? Okay. So from here to here, okay, you are going up, right? Going up. So going up, which means you plus the positive value, 1. Okay. Plus it, go up, plus. And then in the second, but this one I have to be careful. It doesn't really looks the same as this one. So you have to be careful. Now, in the second circle, this one, just now the left, right, I go to the right, so you plus. But now, for this one, the question is up or down, right? Up or down. So from this trace, you can see it going down. So it means that starting from the second one, we have to minus already. Okay, we have to minus the q. So, like, I can label the first one as red color. Okay, try to be consistent with the color, you can see it. So this is minus q. Okay. And then the third one, you look at the third, this one. So from here to here, okay, it's another going down, right? It's another going down. Okay, going down. So minus q square, p, and then and so on. But the fourth one, which means the q3 term, q cube term, sorry. Now this one is already going up, right? So this one now is again plus, and you all know what happened, because two going up, two going down, two going up, two going down. Just like how this one is two going left, two going right, two going left, two going right, two going left, like that. But this one a little bit different. First start from the going up term, and then two going down, two going up, two going down, two going up. Plus, and so on. And so on. Plus q power 4. Right. Okay, this one. And then minus, minus power 5 minus power 6 plus power 7 plus power 8. And the same technique as just now. So we apply the same technique, which we can separate to two different series. So one with all the even power, 1 minus this one, plus this one, minus this one, plus this one. Okay. And then the other one is right. But the second one has to be a little bit careful, because you are starting with minus q and plus and minus and plus. So now you minus q plus q minus q power 5, q power 7 minus. Yeah. Okay. You can do like this. plus this. Okay. So again, your job is to figure out what's the first term and what's the common ratio, right? Okay. So for the pink color one, first term and common ratio is the same as what we have just now. So A is 1 and and common ratio is negative Q squared. So that's the first one. The second one, a little bit different, right? So we have to figure out the first term. So here, you try to see lah, okay? So if you take this one as a first term, right? And then the second one is multiply the first term by negative Q squared. So negative become positive for the second term. And then power at 1, at 2, sorry. So the same process go through, which means the common ratio is still negative Q squared, but just with a slightly thing different, which is your A. The first term is now negative Q. Okay, so negative Q I will put on top. So that's my A, then over 1 minus R squared. Sorry, 1 minus R. So 1 minus R, the same thing here. So 1 minus negative Q squared. And then you write as 1 minus Q, 1 plus Q squared. Right? So here's a X coordinate, here's a Y coordinate that you can. Okay. Okay. This is okay. Again, so refreshing. Why we are finding this? The X prime and the Y prime are the point that the spiral, this pattern, this curve are kind of like converging to, okay? The limit of the endpoint. So this one. So this coordinate is given by, so we use a formula lah, 1 plus P that we have just derived, and then 1 minus Q. Sorry, it's not P, it's Q. 1 plus Q over 1 plus Q square, 1 minus Q over 1 plus Q square. So, this one. Okay. Okay, so this is the coordinate, okay? In terms of Q. Okay. Actually, up to here, actually, I think you can already get like maybe 4 or 5 marks already. So this problem is worth 7 marks. So if you can figure out like this process, okay, already can get some marks, okay? Okay. Now, but our final job is to show that this point actually is in a circle. It's actually in a circle. Okay. In a circle that center at the center of the initial 1 square. Okay, this one quite something. Okay, let's figure out what that means. Okay. There's a circle, okay. This circle has a center, which is the center of the initial 1 square. Okay, center of the initial 1 square. We look at the green color term. Okay. Green color word. Okay. The center of the initial 1 square. Okay, this one, what they're asking, what they're referring to. Now, the initial 1 square is this one, right? So what they want is the center of this one, the center of this square. Of course, is this point, right? So this is the center of this square. Okay, so this point, of course, the coordinate is given by, what's the coordinate? Anyone? Yeah, actually. Yeah, 0.5, 0.5, okay? 1/2 lah. Yeah, so, yeah. So this is the center, okay? Okay, so okay. This is center, okay? And what we want to show is this final value lies on a circle. The center is this one. This is what we want to show. Okay. Okay. We want to show. I use another color. Maybe this one. Okay. Okay. Let's say this is the limit point. Continue to draw lah. Okay. Let's say this is the limit point. Okay. What we want to show is cannot draw. Yeah. Okay. What I want to show is actually that, okay, almost like that, almost like that. Okay, which means this final value lies in the circle. This circle is what we want to find. Okay, it's still unknown yet. This circle has a center at 0.5, 0.5. Okay, 1/2, 1/2. This is what I want to show. Okay. Okay. Actually, apart from that, if you can follow starting from the beginning to this part, you already are very well done. I have to say, really good, really good. Okay. Okay. The next one a little bit more advanced a bit, but I think for those who have covered what is the center, okay. Okay. I think just definitely yes, right? Okay. A circle has a certain equation, right? If you all remember that. Okay. Let's have a quick revision on that. Actually, SPM time also have that. Okay. Right? SPM at maths, right? A circle has an equation in this form. X minus x naught square and then y minus y naught square equal to r square. This one is a circle, right? Circle form. Where x naught y naught is your center. Okay. And then the r, of course, is your radius. Yeah. Okay. So what we want to show is okay, is okay, the xy here is of course the your point, okay? It's of course your point, your point on the circle, okay? The point on the circle. On circle. Okay? The point on circle, okay? And then minus the coordinate of the center, okay? And then do the square and then plus them. This one should equal to some number. This number is the radius square. And this one is a constant. This one must be a constant. Okay, r square is a constant. Okay, now let's have a revision, refreshing that. What we have found is, we have found the point on the circle, which is this one. This is the point of the circle now. Okay, you see, we want to prove that this point lies on this light blue color things. Okay, light blue color circle. So this one now is our coordinate of the point. Coordinate of the point on the circle, right? And from the question given, we want to show that the center is 1/2, 1/2. So our x naught, y naught is already here. This is our x naught, this is our y naught. Okay. And of course, this one is our x and y. The thing that remain unknown is the radius. I'm not sure about what's the radius, but if you can find that, that's good. Okay. So now we want to find that. Okay. Since we already have this xy and this x naught, y naught, can we find whether this equation is valid? So let's try this. Okay. So this is our goal. We want to try to see x minus x naught square plus y minus y naught square. Okay. Is this a constant? If it is a constant, then we are done. Which means that the point on the circle minus the center of a circle is equal to some constant, which means this point lies on the circle. There is a circle. So this is how we want to prove there exists a circle. So our goal is to prove that this is equal to 0. Sorry, 0 pula. Equal to some constant. Okay, constant. Right. So everything already is there. Okay. So now let's try to see what happened to this one. Okay, the left hand side. So now let's substitute with all the things that we already have. So the x coordinate of the circle that I want it to be a circle is 1 plus b over 1 plus b square. X naught is 1/2. Y is 1 minus, p pula, q, sorry. Yes, q. Okay, 1 minus q, 1 plus q square, minus 1/2. And this one has a square, this one has a square. Okay, so I want to show that this is a constant, or in other words, I want to see if I can eliminate all the q. The q must eventually be eliminated. Okay, all can cancel. Finally, I just leave it with constant only. See whether I can do that or not. Okay, this is not a really bad algebra question, right? So just do some expanding the square. Okay. Okay, let's try lah, huh? Okay. Now, this one, okay. If you like using a minus b square equal to a square minus 2ab plus b square. So we can expand this bracket. All right. So this one square minus 2 times. Okay, 1 plus q. I think you all know what to do. Right? And then multiply by 1 over 2. And then plus 1 over 2 square. Or 1 over 4, right? 1 over 4. Okay, another one which is 1 minus q, 1 plus 2 square. Okay, plus 1 over 4. Okay, now we can cancel the 2 here. So, right, simplify the algebra. Okay, and then let's add up the 1 over 4 and 1 over 4 and put in front 1 over 2 here. Okay, and then let's do this one. 1 plus q square over 1 plus q square and square plus with 1 minus q square over 1 plus q square and square. This one got a lot of things. Okay, never mind. I believe it's okay. Okay, now this one is minus, this one is minus. Okay, try to simplify this. Okay, can I just try to make one common denominator for these two terms? Okay, because they have 1 plus q square in common. So we can combine them. And let's just make plus. Okay, anyway, let's just make minus so that we can factorize the negative also. So I just put plus on the top. 1 plus q and plus with another 1 minus q. Yes, sir? Actually, I can do the same thing for this this one also because they have a common denominator also. So this one, connect them with a plus. Their common denominator is 1 plus q square and then square. Yeah. Okay, let's try to simplify this. See whether we can eliminate all the q. Okay. So 1 over 2 plus. Okay, let's expand this kind of monster a bit. Wait. 1 plus q square. This is 1 plus 2q plus q square plus 1 minus 2q plus q square. Okay. Right? Expand the square. And then for this one, something can cut. I think this and this. So we left with 2 only on the top and over 1 plus x. Okay, next. Here, these two also can cut, right? So left with 1 got 2, so 2. And I have 2q square also, so like this. Okay, minus 2 over 1. Okay, now I think 1 over 2 has no problem. The problem is that I want to see whether this is a constant. So now I need to further simplify this term and this term. See whether they are equal. Okay, so I make the common denominator because now this one has a 1 plus q square and square. So I want to, in order to make the common denominator, I have to multiply by 1 plus q square, 1 plus q square. Okay, so okay, so let's make a common denominator now. 1 plus q square and square. Okay, now let's do on the top. So this is 2 plus 2q squared for this part. And then for this part, I have a minus 2 multiplied by this. Okay, so minus 2 times 1 plus q squared. Yeah. Okay. Wait. Yeah. I think that's right. Wait. Did I make any algebra mistake? Wait, let me check that. Yeah, really quick. Wait. Uh. Oh yeah. Okay. Okay. So this is 2 plus 2q squared minus 2 and minus 2q squared, right? So yeah. You see that, right? These two can cut, and this one can cut. So finally, they become 0. So this one just a constant only. So 1/2. Yeah. Okay. Yeah. So this is a constant. Okay. As long as it's a constant, then we done the proof. 7 marks over here. But let's try to make some finalized argument. Okay. So what we have proved that is this one square plus this one square actually equal to some constant 1/2. So which means that okay, the x and the y and okay lah, let's write them out. Okay, the x and y is given by the very long thing lah that consists of the q. This is 1/2, and this is 1/2, and equal to 1/2. So this is the equation of a circle that really about it. Okay, that really what we call the endpoint. The endpoint lies in this circle. Okay, so all we can tell that is this circle has a center of 1/2, 1/2, and the radius is this one. Okay, but this is equal to r squared, right? So r equal to square root of 1/2, like this, or maybe yeah, yeah. Okay, that's about 0.707 something. Yeah. So okay, so the conclusion is of course we have to say that therefore the point of the circle lies in a circle. The point of the circle, sorry, the point of the limiting endpoint. Yeah. Yeah, limiting endpoint. Endpoint lies in a circle with radius, with center 1/2, 1/2, and with a radius of 1/√, and that's it. So this is our final conclusion. But you have to show that. You have to show that this is equal to a constant. So this constant is our r squared, and from that find our r. Yeah. So yeah. So this question, like how another for me, it's a very nice problem that combines some geometry, some APGP, some algebra, and some circle analytic geometry, and all those that thing. Yeah. So right. I think like right. I think like if you like really see properly, like this one is still an okay one, but just that whether like in the real exam that and I'm sorry lah, but at least now you can follow. So that's the main point. Yeah. I'm really happy that. Okay. Well, I think okay, I think the first two problem, like I just show here, is about some geometry, right? I don't want to go through one more geometry problem lah. So we have some statistic frames here. So I think let's do some problem with statistic, okay? Because this one we have some calculus lah, right? This one is actually some calculus a little bit lah, right? Actually, I don't think so. This one don't have lah. But just now, this one just geometry only. This one like a little bit algebra lah. Okay, and plus geometry. Okay, let's do one question that with statistic. Wait, I don't think it's here. Let's go to yeah, this one. This is also last year question. So it's about some expected value. Okay. Yeah, but the modify game like that. Okay, so I think this is the last problem for today lah, right? So just have some okay, some fun with that. Okay. Okay, the last problem for today. Okay. Right. Okay, so let's read lah. So every time you have a feeling that this competition, like they really like to play with a really long story, okay, about something, then yeah, then let's figure out one by one all of each of the statement. What's the info? Why is that even really needed? They tell me this information. Does it represent anything? Right. So this we can ask ourselves. Okay, let's read. There are 256 players in a tennis tournament who are ranked from 1 to 256. Like, badminton, there's some like kind of like a ranking, like world ranking, like Li Zhijia is ranking as a world number 7, something like that. Okay, there's a ranking from 1 to 256. Okay, with 1 correspond to the highest rank and 256 correspond to the lowest rank. So they have some certain rank. Okay. Okay, when 2 players play a match in their tournament, the player who rank is higher has wins the match with the probability 3/5. So which means if your rank is higher, you are more probably to win the game. 3/5 is 0.6, which means you win the game 0.6. If you lost the game, 0.4. But this is about your ranking. It doesn't matter how much you exceed that, as long as you are higher ranking. So this can tell you that okay, your winning rate is exactly 0.6. Yeah, something like that. But this is just a game, okay? Of course, it doesn't happen in our real life, okay? Yeah, so like that. Okay, so this is the situation, the situation. Okay, so now let's see what they want. In each round of the tournament, the player with the highest rank plays again the player with the second highest rank. The player with the third highest rank plays with the player with the fourth higher rank. Okay, so and so on. Okay, okay. For example, let's say we have 8% and rank from 1 to 8. Okay, like that. I give you a small case. Okay, give you a small case. Okay, so the number 1 plays with number 2. Number 1 play with number 2, 3 play with 4, 5 play with 6, 7 play with 8. Okay. For each of the match, the one with the higher ranking, let's say 1 play with 2. Okay. So 1 is higher than 2. So the person ranking 1 has a winning rate of 0.6. So this one has winning rate 0.6. So this one win is 0.6, lose is 0.4. And of course, for the second highest person is the balikan, right? This one win rate is 0.4, lose rate is 0.6, and so on. But the third person is luckier than the second person because the third person need to face with the number 4th person. So in this game, 3 is higher than 4. So this one has a higher winning rate. Now this one has 0.6 for winning and 0.4 for losing. And so on, and so on. So all the odd number person are luckier person because their ranking shows that, okay, yeah, their ranking shows that they actually has a higher winning rate for that the first matches, okay. And those who won, right? Okay, we are, yeah, okay. Let's read the second sentence. Okay, after here, at the end of each round, the players who win proceed to the next round, and the player who lose exit the tournament. Okay, very very normal, right? So this is like kind of like a then at the second round, right? Those who win the first round will place with those who win the second round, right? This is like the normal, right? Because all those person who win, and the first highest person must play with the second highest. So if 1 and 2 only left with one person, and then 3 and 4 left with one person. So of course now the highest is this one, second highest is this one, third highest is this one, fourth highest is this one, and so on. If there's more person. Okay. And then this one, the winner play with each other, and then finally there's one winner. Okay, there's a winner. Okay, now okay, what that one? Okay, after 8 rounds, there is one player remaining and the dominant, and they are declared as the winner. Okay. Okay. So let's say in the small case of 8 person, so we need to play 1 game, 2 game, 3 game, right? Sorry, 1 round. 1 round. I just say round one, okay? Round one. Round one, round two, and round three. Right? We have 3 rounds because this one, and the second round, and the third round, the final 2%, okay? And then there's a winner. So in the case of bigger size, 2, 5, 6%, we need to play 8 rounds, and then after 8 rounds, there's one winner. Okay, of course that is possible, right? Because 2, 5, 6% after the first round, half of them will be eliminated. So which means 1 to 8% is left, lah. And then so on, and then keep repeating this process, which means the next step is 64. Wait, let's try to list out this one. Okay, so round one, round two, and then 32, and then 16, and then 8, and then 4, and then 2. Round 3, round 4, round 5, round 6, 7. So after 7 rounds, there's 2% left. So the last round will decide the winner. Okay, round 8 will decide the winner. So this is the game. This is the game. Okay, what they want is determine the expected value of the rank of the winner. Expected value. Okay, now expected value doesn't mean that. Okay, so this one has something to do with the statistic lah. So if you all must have some statistic basic lah, at least maybe statistic 1, I think. Okay, expected value. Okay, now expected value is the average ranking, which means that the winner most probably in average to be what rank. Okay, now it doesn't say that which person has the highest winning rate. Of course, it's the number one, because the person with the ranking number 1, you play each game, you have higher probability 0.6 over each person. So from round 1 play to round 8, the number 1 person has 0.666. But it doesn't mean that this is the average ranking. Okay, we want to calculate the expected one. Okay, each of the person has a winning rate, right? Okay, so like this, okay, let's say I'm gonna call this as Px equal to 1, which means what is the probability that the first person win the game? Okay, the probability of the first person win the game. Okay, so let's call Px equal to 1. Okay, and then Px equal to 2, right? Okay, so we can calculate all this probability. Expected value Ex is calculated using the follow formula, x multiplied by Px equal x, right? So this one x from 1 to 256. Okay, now this is our final goal, of course. But let's look at some small case first, okay, to understand the problem. Okay, so we have each of the probability, and after all that, what we need to do is to multiply this probability by the ranking. So means that this person corresponds to 1, okay, and has to multiply by its probability of winning the game, okay. So this one will give a number, and then we do the same thing the number two, the second person has another winning probability. Of course, it's smaller than the first one, but we multiply these two numbers to get a second value, and all these number we plus them, and that is called the expected value. So as you can see in the formula here, x multiplied by its probability, px. Okay, px equal to x. Okay. Okay, so this is the game. All right. We are not going to do 2, 5, 6 so big size, right? Okay. Let's just think of the small size. Okay. This is one of the strategy that we commonly use in any problem, which is we consider the small case. Just consider some small size. Okay. And we use this small size as an example to think of the big size. Okay. Okay, actually 8% for me is still considered as too many person. Why don't we consider lesser person? Let's say 4% only. Okay, let's say 4% only. Okay, this one I try to move a little bit. So now let's consider in this comfort zone. Let's say 4% only, still the same situation, but 4% only. So we only play 2 rounds. After 2 rounds, this one is considered as a winner. Okay, this is a small game. Okay, let's consider this small game. So, yeah, no man. Okay. Yeah, let's consider this small game. Okay, this is the case where n equal to 4, and later we try to generalize, see if we can see the pattern or not for 2, 5, 6. Okay. Okay, now we try to calculate the probability that px equal to 1, which means the first person, if he want to win the game, what is his probability? Okay. Now, I think let's figure this out in the next page. I have not enough space already. Okay. Oh, yeah. Right. Still okay, right? The story. Okay. Story. Okay. Okay. Now, so let's consider the case of 4. Okay. So all right. Let's see. Okay. Let's say the first person ranking 1. Ranking 1%. Okay. He has to play 2 rounds. Round 1, he will face the ranking 2%, right? And round 2, if he win, he will continue to the round 2 and play with the winner from 3 and 4. Okay, the winner from 3 and 4 will play against, let's say if the person 1 win, he will play with either 3 or 4. But the ranking is still higher, right? For 1. 1 is higher than every person. So in the round 2, he also has the same win rate and lose rate, 0.6 and 0.4. Because this game is like that, right? This game is as long as your ranking is higher, doesn't matter if exceed how many ranking, your win rate is always 0.6, a bit higher than 0.4. Okay, so the ranking 1%, if he want to win the game, the probability is given by 0.6 multiply 0.6. Okay, right? 0.6 for winning the first game, and then 0.6 for winning the second game. Okay, this one is the probability of this person winning. Okay, yeah, try to do like that. Okay, or maybe before you do that, you can like state a general statement like let tx. Okay, so if you have some statistic basic, you know that this big X stand for a random variable. This small x stand for the index, like the ranking, stand for the ranking of that person. Okay. This probability P means that the probability of the ranking ranking X person player to win the game. Okay, so we just calculate the probability of winning. Okay, so this person to win the game, so has to pass through 2 rounds. First round 0.6, second round 0.6. So that is the winning probability. So 0.6 and 0.6 is 0.36. So okay, for this one is actually very quite commonly that we do a table, right? So we can do a table for it. So x, this is the p x equal x. Okay, so can do make a table for it, and that looks better. So when x equal to 1, this is the correspond probability. Okay. Well, let's think about the second one. Okay. The second person, second ranking person, if he or she want to win the game, of course, the first round, he play with the ranking 1 person. Now, this person has a lower winning rate, which means 0.4 for winning, right? Because as this one show, right? This one win rate is 0.4. Okay, so let's say if he want to win, the first game is 0.4. Right? Okay, but 0.4 multiplied by what? Is it still 0.4? Okay, let's continue the thing. Let's say he already win and proceed to the next round, round 2. This time around, this second ranking person will face with the winner from 3 and 4. Which one is higher? Is the 2 higher or the 2 lower ranking now compared to the winner from 3 and 4? So the winning rate is, right? Okay, right? So 3 and 4, whoever, if the 2 person come out, okay, faced with 3 or either 4, the 2 now is higher. Okay, even though the first round he is lower rank, but faced with the second time, the winner from this poll, okay, faced with the second person now is higher. So in the second game, the win rate now is 0.6, still 0. It's changed to 0.6 already for the second person. Okay, so so that's why this one is 0.6. Okay, for second person. So from here, okay, face, and then to win 0.6. Okay, so this one is 0.4, 0.24. Yeah. Okay, next, x equal to 3. Okay, so we use the same argument. So for each of the game, you have to consider whether he faced with the higher ranking or lower ranking person. If higher ranking, then if he is the higher ranking one, then winning rate is 0.6. If he is the lower ranking one, then 0.4 for win rate. Okay, now let's consider the third person. Third person, first game is lucky, faced with number 4 ranking. So now he has a higher winning rate of 0.6. Okay, but after the first game, if he go to face with the winner from first 4, 1 or 2, now this person is a lower one, right? It's a lower one. So now his win rate is 0.4 for the second round. Okay, for the second round is 0.4. So you can see the difference. Okay, second player, first game is tougher, but the second game is better. Okay, the third person, first game is better, and the second game is tougher. Yeah. So still the same 0.24. Okay. Well, the last person, okay, no need to think because the last person face whoever player the last ranking already. So the win rate is 0.4 for the first game, face with the number 3 person. After he win, if he win, we'll face again with a 1 or 2 person, still the lower, so 0.4 again. So it's 0.16. Okay. Okay. Now with this one, it is not too bad that we can calculate its probability. Expected value. Okay. Let's say I want to calculate this expected value lah. Okay. See whether we can. The x for this for the small case okay. But this is a small case, not a final answer we want. So I can try to label here as 4 to stand for the total size is 4. Okay, if the total size is 4, then can be given by 1 multiplied by 0.36 plus 2 multiplied 0.24 plus 3 multiplied 0.24, and the last one is 4 multiplied 0.16. Okay, this is multiplier, multiply, 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 and multiply. Okay, so here we can get okay, that's 2.2. Okay, 2.2. Not a very easy guess number lah. Okay, so that's for the person of 4. So which means that the average person coming out, which is still a little bit higher than the ranking of wait, how do we say that? This 2.2 is actually favor to up. Okay, why did I say that? Because the midpoint, the midpoint here is actually 1 plus 4, right? Divided by 2, so that's 2.5. So if this is a fair game, this is a fair game. Like everybody is randomly facing anyone. So like 0.1, 0.5. So you will finally get your midpoint is 2.5. Then your expected value should also be 2.5. But that is the case where if it is a fair game. But let's say now with a ranking thing, okay, so it's actually now the average number of the ranking will be 2.2, which means a little bit favor to up. That is normal because we rank from here to here, from up to down. So the final person sitting there is a little bit biased to the either the number 1 or number 2. Of course, number 1 has a highest winning rate, as you can see here. Okay, 2 and 3 are the same rate. Okay, but this one is a lower rate. Okay, but that is just the EX4, the expected value for the case where the size is 4. Okay, now with this information, we can go to like generalize a bit. Let's think about double the size, like 8%. Okay, let's think about 8%. Huh? Okay, we can do in a similar way. Okay, now let's consider another 4% from 5 to 8. 5, 6, 7, 8. These four different ranking person. Okay, so now we also play a game in between these 4%. Okay, of course you say it's 8%, but yeah, but before the round 3, can't this one also play with this one also play with this one, and then the winner also come from here, right? And then finally this one go with face with the winner that come from the pole 1, 2, 3, 4, right? So this one has a join with this one. Okay, so that is the round 3 thing. Okay, so can we like first consider what happened to the person 5, 6, 7, 8? Okay, what is the what is the expected value for 5, 6, 7, 8? Okay, why I want to do so? Wait, can I? Okay, so here I do a small thing. Wait. Okay, we try to we need to think about more. Okay, now for 5, 6, 7, 8, let's say to win the game, you can see that this one is actually very similar to the case of 1, 2, 3, 4, because the ranking is still the same. Now, 5 actually is kind of like the place in person 1, ranking 1. 6 actually similar to the ranking 2 person, and then 7 similar ranking 3, 8 similar to ranking 4, right? Just that they are ranking all +4 only. Okay, but the situation is the same if they want to go out from the round 2. This is round 1, this is round 2. So which means that the person 5, if he want to pass these two rounds, hey, hi, Gokson, I just come. Okay, never mind. Actually, I'm about to end, but never mind. Okay, I have a recording. Okay, so like the person sitting in the place 5, if he want to win this game, also has the same probability because this is 0.6, this is 0.6 for this person. Okay, in order to pass through round 1 and round 2, because the ranking 5 person as compared to 6, 7, 8 is still the highest person among here. So 0.6 is the same. This one 0.4, 0.6, right? 0.4, 0.6. And the number 7 person 0.6 first, and then 0.4. And then this one 0.4, 0.4. We can draw something easier like this. Okay, easier for us to figure out what happened here. Okay, then final, then their winner come from here and then to face with the upper one. Okay, and the upper one face with down one. Okay, now let's think about something. Now let's say we want to play the round 3. Round 3 will be just one game only, which is the winner from 1, 2, 3, 4 are going to face with the winner from 5, 6, 7, 8. They're face together. Now it's the same situation as just now, that the winner come out from this one, of course has a higher ranking as compared to the winner come out from here, right? So still the same situation that this person has win rate 0.4, a little bit lower, and then this person has a win rate of 0.6, a little bit higher. Okay. Now you say how to calculate this? Okay, now I will say like this. Okay. Now with a little bit more multiplication. Okay. Okay, you can use this table as a reference. Now let's see. Let's say we do the case of 8. Okay. So now we list our x from 1 to 8. Okay, we add 4 more values. Okay. Okay. Of course, the probability is now different already. Okay, it's now different already. Okay, let's figure out what happened. Okay, now all this person from 1 to 4. Okay, after these two values are the round 1, round 2 probability. These are the round 1 probability. These are the round 2 probability. I can highlight that. You know? Okay, so these are the round 1, round 1, round 1. Okay, and round 2. Okay, now of course we want to add another value, which is the winning rate for the round 3, because he already come out from the upper pool. So each of this person, if he already win 2 games, the next game for this person to win, of course, is 0.6 for all of them. For all of them. Okay, as like just now, okay, in the round 3 game, they are in the higher ranking. So this is a round 3 game. Okay, so this modification tells us that I can for all these value that I already have, but I have to multiply by another 0.6. Now this tell me that okay, without really doing it, if you really want to do, it's going to be a very boring thing. Okay, but let's think about that. This all number, after that we have to plus them out, right? Have to plus them, correct? Is it the same that has a common factor of 0.6? And okay, what I mean by plus them out is this probability has to this probability has to multiply by the x, right? So it's kind of like another one more table. This one is x multiply px. Okay, for us to calculate the expected value, we have to multiply this value and this value. Okay, this value and this value. So this is a value. Okay, so 1 multiplied by 0.36 multiplied by 0.6. I try to don't multiply first the 0.36, 0.6. I want you to see something. Okay. 0.6 and 4 times 0.16 times 0.6. Okay, now you see, this 0.6 is an extra thing because of I introduced that this is the game for more person. Okay, for the 8%. So that's why that all of them has an extra 0.6. Now you can figure out that if I only consider this one plus this one plus this one plus this one, which is exactly our E expected value for 4%, right? And now for each of them has to multiply by 0.6, 0.6, 0.6, 0.6. So I think the total value for this all thing should be E of the 4%, the expected value for the 4%, and multiply by 0.6. Makes sense, right? Right? Makes sense, huh? Because, right? Because this one, yeah, because this one is the original one, and then each person has to face one more game, right? And their standing is still the same. So so all of them has a factor of 0.6, and then that will be the new expected value for the first 4%. Okay, but hold on, haven't finished yet. Okay, if we have this idea, actually we can better, easier to do. Okay, now let's think about the case of the person 5, 6, 7, 8. This 4%. Okay, now you see this 4%, as I say, their round 1, round 2 is actually similar as 1, 2, 3, 4, correct? Their round 1, round 2 is actually similar, which means for the person in the place of 5, just like I said, 0.6, 0.6. So this is 0.6 and 0.6. Okay. The first two round, the person in the place 5 has the same thing as the person in place 1, as compare, but only differ in the third round. The third round come out, go there, so face with the person in the first winning pool, of course, has a lower winning rate with 0.4. So the round 3, 0.4 is for the person place 5. Okay. This one holds true for all 5, 6, 7, 8%. So which means all of them has another 0.4, right? As long as they win, as long as this 4% win, it go out and face the person winner from 1, 2, 3, 4 has a lower winning rate. So 0.4 for the round 3. But it is the same situation for round 1 and round 2. So I can just copy paste this part and paste here a little bit. I'll try to make it smaller, right? Like that. Okay. The situation is the same. Okay, for round 1 and round 2. Okay. And I try to calculate that. Yeah. Okay, I try to calculate that. So which means that so this one is also 0.36 for the first two number multiply together and then times another 0.4. Don't try to multiply that because, as I said, you can figure out some algebra property and then make the calculation easier. So this is 0.24, 0.24, and 0.24. Sorry, 0.16. And then all of that multiplied by 0.4, 0.4, 0.4. Okay. Okay, now your job is to multiply this value by the x, right? To calculate x times px. Okay. Yeah. Here got no place already. I try to put here. Okay. Okay. Wait. Okay, never mind. Try to put up. Try to move the table, go up. Okay, for some space. I think 5, 6, 7, 8. Okay, the case for this one. Go down a bit. Okay, like this. All right, let's continue. Okay, now let's calculate for the person of 5. Okay, now so you need to see like this is a 5 times 0.36 times 0.4, right? 6 times 0.36 times 0.4. and then 7, and then 8 times 36 pula. 24 lah, 24 and then 0.16 lah. Okay, the similar pattern, except that this one has a something as a little bit modification, which is yeah. Okay, now my job is to, can I calculate this one without really calculating it, but I try to use some previous number. Let's say, can I express this number in terms of EX4? Has something to do with EX4. Okay, now my job is to calculate this whole thing. 1, 2, 3, 4. I try to express it in terms of EX4. Can I do that? Okay, now here's a small thing that I do. If you look at EX4, the first term is 1, 2, 3, 4, but this one is 5, 6, 7, 8. Okay, I can write 5 as 1 plus 4, right? I can write 6 as 2 plus 4. I can write 7 as 3 plus 4, and I can write 8 as 4 plus 4. You will see why it's useful, right? I think maybe some of you can see already. Okay. Yes. Okay. Now. Okay. Now. Okay. I think first thing first lah. This times 0.4 is a common factor. I think let's just factor out this one. Okay. 0.4 times. Okay. The left thing inside. Okay. I try to separate to two parts. One. All those. This one. Okay. So which means this one multiply this. Okay. 0.4 already taken out, so no problem. And this one multiply this, and this one multiply this. So this one is 1 times 0.36 plus 2 times 0.24 plus 3 times 0.24 plus 4 times 0.16. Now this number is very famous, right? Like you go back and you see, hey, this is exactly our EX4, right? Exactly our EX4, yeah, correct, right? This one, EX4. I can go back, see how we calculate EX4, right? EX4 we plus this all number, okay? This is 2.2. Okay, so now I got something, okay? And then I need to plus with all those remaining number. Remaining number is 4, 4, 4, 4. Okay, 4 times this all number, which is 0.36 plus 4 times 0.24 plus 4 times 0.24 plus 4 times 0.16. Okay, try to simplify this as possible. Okay, now, so 0.4 is outside. And then inside, the pink color one is our EX4, right? The expected value for the person when it is 4. Okay, well, when the size is 4. Exactly, right? Exactly. And then for this part, okay, another 4 can be taken out as a common factor. As you can see, everything has a 4. This 4 just basically that all the, okay, the reason is because that all the 5, 6, 7, 8% are 4 place higher than 4 place higher than those in 1, 2, 3, 4%. Okay, so that's why there's an extra 4 come out for each of them. And then 0.36 plus 0.24 plus 0.24 plus 0.16. Okay, this one. Okay, now this is just if you like have some feeling of this, this one, if you plus out, you become 1. Okay, of course it's 1 because the probability that everything plus out must be 1, right? From random variable, right? Random variable, the sum of p x equal x must be equal to 1. This one must happen. Okay, must happen. So this one just 1. So let's rewrite. Okay, I can see something. 0.4 multiplied by e x4 plus 4 times 1. Okay, 4 times 1. This one no problem. I'll just 4 only. Okay, plus 4 only. Okay, so this is the new. Okay. For this one is just for 5, 6, 7, 8% only. Okay, so I calculate here. 0.4, 2.2 plus 4. Okay. About okay, 2.48. Okay. Okay, now, but our job is to calculate EX8 now. The expected value for the person for a random variable when it is at 8. Okay. So means that we have to calculate all this one from here, 1, 2, 3, 4, plus 5, 7, 8. All this person. So yeah. Okay. So this one we have already calculated, which is EX4 times 0.6. Yeah, EX4 times 0.6. So yeah. Okay. I without writing this one, can I just copy this one? Because later I can refer to something. Okay, this one is 0.4. This one. Okay, this is the first part. Actually, this is the second part. The first part is from number 1 to number 8. I try to write out this one. Like the formula is x equal to 1 to 8. And then xp. Okay. Okay. Formula for expected value. Okay. So in each of the process letter, I will try to separate to half the person from 1 to 4 and the person from 5 to 8. So they have a different calculating strategy, where the first one is using the previous expected value E of the 4 and multiply by 0.6 and 0.6. Try to use a different color. So let's say okay. Basically just because that the previous part, okay, for the half of the size for the first pole, if you win, you have to another 0.6 of the winning rate. So that's why I have to multiply by 0.6. Well, for the other part, 5 to 8, the lower half, okay? Lower half. This half person has a winning rate as follow, has an expected value as follow. Also the O part, but we plus 4 because that every person has an extra ranking 4. In this case, okay, in this case. And then after that, when they go out, they have to face another high losing probability game, which is multiplied by 0.4. Okay. This one is the general way of calculation. Okay. So with this, let's substitute 2.2. Okay, here we can get our E8 is 4. 3.8. 3.8. Okay, 3.8. Yeah, correct. 3.8. 3.8. Yeah, 3.8. If you do 1 plus 8 over 2 is 4.5. This is the midpoint. This one still a little bit must a little bit favor to the first pole person. Okay, the expected one should be a little bit lower, which means favor to the higher ranking person as compared to the midpoint. Now this one just a checking on it. Checking. Okay, must be bigger. Okay, now let's think about what happened to the 16%. I'm not gonna do everything again. So let's think about what's a general process. Okay, a general process. Yeah, and what can we do? Now, if I want to calculate E16, so I double the size, right? Double the size. So this is already what happened to the 8%. Now, the expected person come out from here, of course, has a higher winning rate as compared to the starting from number 9, 10, 11 to 16. Okay, so that the expected person come out from here from 8 now has another 0.6 multiplied by 0.6 as a higher winning rate. Okay, plus, so this is the first half. The first half, I didn't write that already because this is 1 to 8. Actually, okay also. I try to write one more time. Okay, so now has changed to the person from 1 to 8. And then the second half will be from 9 to 16. Okay. And now the expected value from the first 8% multiply another 0.6. Now for the second half, we can actually copy a bit for formula for the just now one. Okay. What happened just now is the O expected value, which is now O is 8. Okay, just now plus 4, because each of the person, the 5, 6, 7, 8 compared to 1, 2, 3, 4, all greater than 4 ranking. But now the situation is a little bit different because we are now saying that the 9, starting from 9, 9, 10, 11, 12, 13, 14, 15, 16, as compared to 1, 2, 3, 4, 5, 6, 7, 8. The situation is similar, right? The situation is similar from 1 to 8. But all of them has an extra ranking 8. Extra ranking 8. So here, the modification here is plus 8. And then multiply by 0.4. The 0.6 just also same. They basically come because lower pole. Okay. So we use back this formula like to calculate everything. So we use back lah. So it's like a recursive formula. So when we understand this one, then 32, 64, 128, 3, 256 can be calculated in the same similar way. Okay. So let's try to just finish that. Okay. 0.6 plus 4. This is 3.8 now. Okay. And then let's do one more, I think. But because the behind process is almost the same. 0.4 times 3.8 plus 8. So this is 7. And the next one, I just give the number only, okay? Because we already know what happened here. So 32% will be previous value 7 times 0.6, the first half, plus 0.4 times the previous value plus 16. Okay, each of the time this plus value have to double the value because of the ranking factor. So like 7 times 0.6 plus 0.4 times 7 times. Okay, 13.4. And then we do the same process as M. I'm not gonna do everything because the same thing only. Okay. Okay. So let's write out the. I just give the final answer of what I've done last time. So the final answer is 103. 103. 103. So using the same process. Okay. Oh, okay. Yeah. Yeah. 103. Yeah. So doing that, and then the final answer is 256 is equal to 103.0. Yeah. The final answer. Okay. Fine. Okay. I think I just stop the recording here. Okay.